Hi there, welcome to the second video in the logs and exponential topic. Just now we're going to look at laws of logarithms. Okay, so two things you need to be able to do: be able to simplify a logarithmic expression using the laws of logarithms, and then solve logarithmic equations as well. Okay, so I'm going to show you 5 laws of logarithms. I'm just going to talk about them very briefly. Okay, I'm not going to show you full proofs, but these are the 5 laws of logs. Okay, now remember that logs ask us what the power is. So looking at our first one there, that log 1 to the base a is saying, right, a to what power gives you 1? We know that 0 is always a power that gives us 1 here. Log to the power 0 will give us 1. Okay, second one there, log a to the base a. Okay, a to the power what gives you a? Well, we know that's 1. Okay, now this here will be particularly useful for us in a wee bit in terms of solving equations. Okay, now the next 3 are all very closely related to the laws of indices. Okay, we're talking about powers in a kind of inverse way, but we're talking about powers. So we know that when we're multiplying with powers, we're adding the powers. It's the same, but the other way around here. Okay, when you are adding 2 logs, that really means you're multiplying what's in there beside the base. Okay, same when you're taking away, that means it has to be divided. Okay, and the last one is if you have an n in the power here, if you have a power, then that power can fly down to the front. Okay, and vice versa. Okay, so the n can go to the front or it can go from the front up to the power. Okay, so these are the 5 ones you need to remember them, but practice you remember them very, very quickly. Okay, these are the 5 we need to know. Okay, so looking at those laws there, I'm going to ask you again, I would pause the video and try and evaluate those 3 laws. So to simplify, I and evaluate each one of these will give you a number. Okay. Okay, so first one here, we've got 2 logs that have been added together. So that means, okay, that they're going to times in your 5 by your 200. So this is log 1000 to the base 10. Okay, the logs have to be the same base, but they will be essentially. Okay, then we're asked for the power. 10 to the power what gives you 1000? Well, you know, 10 times 10 is 100 times another 10 is 1000, so that has to be 3. Okay, second one here, we're taking away, bases are the same. So because we're taking away, we're going to divide. So 63 divided by 7 is 3, and log 9 to the base 3, we know it's my favourite log, is 2. Okay, because 3 squared gives you 9. And then lastly, we have this number at the front. Because the number's at the front, it's going to bounce up to the power. So it's 16 to the power of a half. We know the power of a half really means square root. So the square root of 16 is 4. And then that's asking us 2 to the power what gives us 4? Well, 2 squared gives you 4. Okay, so that's using each of the kind of main laws without the kind of tricky ones at the start. That's the 3 kind of most common ones that will come in. Okay, and we're going to use them to solve equations here. Okay, now the best way to solve logarithmic equations, or the way that happens with the majority, and we'll look at the exceptions in the next video, is you get a single log. Log of something is equal to log of something. Okay, so you get your single log on each side. Log to the base of a of something is equal to log to the base a of something, because if you can do that, then you know the somethings have to be equal to each other. You can cancel out your logs essentially. So you're looking for single logs on both sides. Okay, so give it a wee pause, give it a try. Okay, so firstly, a, you've got 2 logs being added together there. So that's going to be log to the base a of 13x. Because you're adding your logs, you're going to multiply what's in there beside your bases. So 13 times x is equal to log to the base a of 39. Okay, then single log. So cancel out your logs, and you're going to be left with 13x is equal to 39. And then nice and easy, that means x is 3. Okay, now that, for the majority of logarithmic equations, they're very obvious spot ones you're going to do this. Single log, cancel your logs. Okay, so same here again, we're adding 2 logs, so we're going to times what's in there beside the bases. Okay, and then it's going to be log 11x to the base a. Single log of something equals single log of something. So cancel the logs, and your 2x plus 1 times 3x minus 10 is equal to 11x. Okay, then we're just solving that equation. How many logs I've gone, we're just solving equations. Okay, we know to solve these equations, they need to be multiplied out equal to 0 and then factorised. Okay, so 6x squared minus 20x, add 3x is minus 17x, minus 10 is equal to 11x, and then get all your expression, get all your terms to one side, so it's minus 28x, minus 10 is equal to 0. Okay, so 3x squared minus 14x minus 5 is equal to 0, which is going to be 3x and x, minus 5 plus 1, so x is negative a third, and x is 5. Okay, now that's not us done there, okay, because there's a condition in the question here, x has to be greater than 0, because x equals negative a third can't be the case, and the reason x has to be greater than 0, the subject has to be greater than 0, remember your logarithmic graphs can't do anything, you can't do anything about x being less than 0, okay, so it'll say in the question what you need to be working towards. Okay, so there's a single log, okay, I'm going to do 2 more examples. Okay, have a look here. There's a little bit of an issue. Have a look at it, pause it, see if you can figure it out. Okay, so in this case, we have an issue in that we have a term in each question which does not have a log attached to it. Okay, so in this case, what we're going to do is we're going to put a log into the equation. Okay, now remember that log a to the base a is equal to 1. Okay, because you're asked for the power, so a to the power what gives you a? Well, that has to be a to the power 1. Okay. Okay, so then just get back a slide there. Okay, so this I like to call my phantom log. Okay, log a to the base a, and basically means I can put in a log whenever I want because we know there's always going to be like a 1 there that we can use. Okay, so first things first here, I'm going to get a takeaway on this side. So I'm going to divide those subjects, so ax minus 2 divided by x plus 4 on the left hand side, and on the right hand side I'm going to put in a log a to the base a. Okay, now in this case my base is 5, so I'm going to put log 5 to the base 5. Okay, and I call that my phantom log. So my phantom log is going to come in there and give me that single log that will help. Okay, then I can cancel my logs. So ax minus 2 over x plus 4 is equal to 5, and deal with the equation. So times both sides by x plus 4, times both the x and the 4 by 5, and then solve 3x equals 22. So x is 22 over 3. Okay, this one here, again, this 3 doesn't have a log in it, so I'm going to put it in. Okay, so that phantom log there is going to be log, my base here is 2, so it's 2 to the base 2 that's going to go in. You know your base has to match your subject, and you want your bases to be the same so you can deal with them. Okay, now the problem here is I've got a 3 at the front there, so that 3 is going to have to become a power. So it's going to be log 2 to the 2 cubed, so that the next thing we can do is add these two together, so it'll be log x to the base 2 times 8. Okay, I'm just going to change that up a little bit. So log to the base 2 of 8 times x, so just of 8x. And then your single log cancels, ax equals 7, so x equals 7 over 8. Okay, so apart from the sections we'll look at in the next video, you're getting your single log, and then cancel. Okay, so 2 things we need to be able to do. Simplify using the laws of logarithms, so when you're adding 2 logs, you're timesing. When you're taking away 2 logs, you're dividing, and then the power to the front. The power can be at the front, or the number at the front can go to the power. Okay, and then solve simple equations by getting your single logs and cancelling them out. Okay, thanks for listening.